Okay, I'm now going to look at the second example where it says a particle is moving in 2 dimensions with a constant acceleration. The unit vectors 1, 0 and 0, 1 are pointing east and northeast respectively. So first of all, 1e, what that's basically telling us is that is east, and 0, 1 is north. So that's what it's telling us first of all with that first part. Initially the particle is at -1, 2 meters, which means that we can say that r, because remember that's given as the position, is -1, 2. It says with a velocity of 2 minus 3. So because that's the initial velocity, I'm going to call it u, and we end up getting 2 minus 3. It says after 4 seconds, so t is equal to 4, the particle has a velocity of 22.27. 22.27, and that will be our v. So you can see that we're starting to use the Suvat equations here, and it's asking us to work out the acceleration. So the acceleration is v minus u, the final speed versus the initial speed, take away the initial speed, divided by the time. So we can plug this in, and we've got 22.27 minus 2 minus 3 all over 4. And if we do that, we end up getting the acceleration is 20/30 times by a quarter. If I just try and make it a little bit neater, which means my acceleration is equal to 5.6. So that's the first part, calculating the acceleration, and we end up getting, oh sorry, that's not 6, is it? That's 7.5. So 5, 7.5, half of 30, then half it again, 15, and then 7.5. So then the next part of the question is asking, find the velocity of the particle at time t and use it to find the time at which the particle is moving. So this time we're looking for the velocity. So if I take v is what we're looking for, which means that we can use the Suvat equation, u plus a t. And again, a is just what we've just worked out. So we've already got the initial speed of 2 minus 3, which means the velocity is going to be equal to 2 minus 3. The acceleration, which we've already worked out, 5 and 7.5. And the time, which is, well, it's saying at any time, isn't it, for the question. So at the time, so we're just going to leave that as a t. Now we can simplify this, because remember, this can be multiplied through because it's a scalar unit, and we can just leave it in the vector. So v is equal to 2 plus 5t minus 3 plus 7.5t. And that would be the expression for the velocity. Now the other part of the question, it says, and find the time at which the particle is moving northeast. So if we come back to this, northeast is going off between north and east, so it's 45 degree. Now 45 degree, as you're aware, will end up being an isosceles, which means the east direction has to equal the north direction. So they're going to have to equal each other. So we can end up putting them together to say 2 plus 5t must equal minus 3 plus 7.5t. Add 3 to both sides, take away 5t from both sides, and divide through by 2.5 to get the time is equal to 2 seconds. Now part 3 says calculate the position of the particle after 4 seconds and how far has it moved from its original position. So it's starting at minus 1, 2, which means we're going to have to use the formula where we've got r plus, the total distance take away the initial one will equal the initial speed times by the time plus half a t squared, where a is the velocity vector. And it's going after the t equals 4, so we can now sub in our values. So we've got r minus, open bracket, minus 1, 2 is equal to the initial speed, 2 minus 3, times by the 4, plus half of the acceleration, which is 7.5, times by the time, which is 4 squared. Okay, so we need to then neaten this bit up. So if we multiply through, we get r minus 1, 2, 8 minus 12, plus 16, and then half it is 8, 8 fives are 40, and 7.5 gets us our 60. And what we can now do is we could add the minus a half over to the other side and combine them all together to get our r value, which ends up being 47.50. That ends up being our r. So the position after 4 seconds is 47.50, and then if it's wanting the distance from its starting point, then the distance from its starting point is going to end up being, I'll just move this way, distance from the starting point is going to end up being r minus r0. Make sure I'm still in the picture. And if we then do that, so it's going to be 47 minus the minus 1 and 50 minus 2. And we are going to have to work out the magnitude of that. So we end up getting 48.48. If I just come down here, 48.48. And now we can work out the magnitude of that. So squaring, adding together, and we end up getting 67.88 or 67.9 from its starting position.